Hi everyone, today we're going to see what is the difference between equation and function. Practically it's going to be the same, but some specific characteristics are going to distinguish the equation and the function. First of all, I'm going to write an algebraic expression. For example, if I write x plus y, everybody knows that this is an algebraic expression. But if I have here a sign of equal, maybe equal to 2, this is going to be not an algebraic expression. Algebraic expression is just when you have an algebraic elements. But here, the thing is that I'm going to add an equal symbol, and this equal symbol represents an equation. So in that case, I'm just going to have an equation. And remember, that equation could be represented in different forms. One of these forms is the algebraic one, that is this one, is in algebraic form. But if you want to express in other form, you can express it in maybe in a graphic form, or maybe even in a table of values. Okay, first of all, we need to see what are the elements of an equation. As I told you, the symbol equals represent an equation. Equals means equal, okay, from equation. Equal means that all the numbers or quantity that I'm going to have over here is going to be the same like the other side. For example, if here we're going to have a condition. If x value is 1, obviously y value should be 1 too, because 1 by 1 is going to be 2. But this is not only the solution that I'm going to have. For example, if I say that x is going to be 0, y is going to be 2. So as you can see, we have a condition over here, and we have a lot of solutions. Okay, so what are the names of these two literals that we have over here? Well, an equation is composed by variables. I'm going to write variables, and then we are going to have an equality. And that equality is the condition that I told you that we need to have. All the quantity added over here should be the same quantity that we have over here. Okay, so this is going to be equal to this. Okay, this is the elements that we have in an equation. If I want to represent the equation in other form, for example, in a graph, what you should do? Maybe you are going to think that you should make a table of values, and then according with that table of values, we're going to make the graph, so we can do it. But what is the first step to make the table of values? Okay, we need to clear the variable, but the question is which variable? We need to clear x variable, or we need to clear y variable? So the answer is it doesn't matter. So we can clear the variable x, or we can clear the variable y. So here we're going to have two ways to do it. In one way, I'm going to clear the variable y, and then I'm going to say y is equal this variable that is positive. I'm going to pass negative, and then I'm going to say 2 minus x. Okay, so this is, look at this, this is the same equation but expressed in other form with the y variable cleared. In that case, I'm going to clear the variable x. The variable x here, clear it, is going to be something like that one, because y is positive, it's going to pass negative, and then I'm going to have 2 minus y. Okay, so we have two options, two different options. Then I'm going to make in that option, and in that option I'm going to make the table of values. I'm going to write over here x, and then I'm going to write y. Okay, let's do it over here, and here is going to be the same, x, and in other hand y. So my question right now is going to be, okay, to which variable you should give values, the value that you want, to x or y? Well, it depends. In that case, the conditions is that according with the value of x, you are going to obtain the value of y. So it means that the numbers that you are going to assign is going to be of x. I'm going to write over here -2, -1, 0, 1, and 2. Okay, so I'm giving values to x to get the value of y. In that case, I'm going to give the values to which variable, x or y? Well, in that case, it's going to be to y, because according with the value of y, I'm going to get the value of x. So here I'm going to write -2, -1, 0, 1, and 2. As you can see, we have the same equation, but in different representation, but it's going to be the same. And according with the representation that I choose, I'm going to write the table of values in different way. Okay, how to get the value of y according with the value of x? Well, in that case, it's just you need to substitute, and then you're going to have y is equal to 2 minus -2. In that case, it's going to be 2 plus 2. The answer is going to be 4. Okay, so next one is going to be 2 minus -1. So you're going to have 2 plus 1. This is going to be 3. And you need to do exactly the same procedure over here. So here we have 2 minus 1. This is going to be 2 minus 1. This is going to be 1. And finally, it's 2 minus 2. This is going to be 2 minus 2. This is going to be 0. Okay, so according with the values of x, we got the value of y. So that's why it's important to choose the corresponding variable. All right, so in that case, it's going to be the same, but instead y, we are going to get x. So x is going to be 2 minus -2. In that case, the value of x is going to be 2 plus 2 is going to be 4. Okay, we got 4 over here. Here x is going to be 2 minus -1. 2 plus 1 is going to be 3. And then here x is equal to 2 minus 0 is going to be 2. X is 2 minus 1, going to be 1. And finally, x is going to be 2 minus 2 is going to be 0. Okay, as you can see, we have, for example, what happened with this point? This point 0, 2 is exactly the point that we have over here. This point 1, 1 is this one. 2, 0 is this one. Of course, it's going to be the same one, because remember, this equation, this and this are the same, but in different representation. Okay, so that's why we're going to have the same points. Not always we're going to have exactly the same points according with the choose that we decide. Okay, but we're going to have the same points because we are talking about the same equation. Okay, right now we're going to make, look at this, we're going to make the graph of, I'm going to make the Cartesian plane, in that case both, and here I'm going to have x and y, and here I'm going to have x and y too. Okay, so here we're going to start with this one. So the first point that I need to graph is -2, 4. It's going to be 1, 2, negative, 1, 2, 3, 4. Okay, so it's going to be this. Second point, -1, 3. -1, 1, 2, 3 over here. 0, 2 is this one. 1, 1 is going to be this one. And 2, 0 is going to be this one. Okay, so we can make the graph of, I'm sorry, suppose it should be a straight line, but sometimes it's difficult. Okay, there you go. This is the straight line. Okay, this is the equation y equal to 2 minus x. Okay, so here we're going to make the first point. The first point is 1, 2, 3, 4. 1 minus 2 is this one. Next one is going to be 3, -1 is this one. 2, 0 here, 1, 1 here, and 0, 2 here. Okay, so let's make the graph of, and as you can see, As you can see, it's going to be exactly the same, but represent in different way. Okay, well, as you can see, here we have a straight line as a graph. In that case, we are talking about an equation of first degree or first degree equation, and first degree equation always gonna be a straight line. In that case, we have, well, the same straight line in different ways. Well, everything that we have already done to this point is going to be an equation. Equation is an equality when we have two variables, okay? And you can represent in a table of values and in a graph, and obviously algebraic in algebraic form. But look at this. Here we're gonna see something very important. Here we have something extra that, well, is implicit in an equation, but right now we're going to see in specific. The thing that I'm talking about is the condition. We have a condition. Why? Because look at this. For example, in the first one, we decide to give values to x because according with the value of x, we are going to get the value of y. But here, we decide to give values to y. Why? Because according with the value to y, we're going to get the value of x. So here, it's when we are talking about a condition. But what is that condition in an equation? Well, that condition represents that right now we are not going to have just variables. We are going to have two different variables. One is going to be called independent variable, in the other one is going to be a dependent variable. Okay, here I just have variables, but here we have independent variable and dependent variable. The independent variable in that case is going to be x, and here is going to be y. So it means that independent variable not always is going to be the same variable. I mean, sometimes people think that always the independent variable is going to be x, but no, it's the more usual, but it's not a rule. The independent variable is going to be the variable where you are going to give values. It doesn't matter the numbers that you want to give. Well, sometimes it matters, but in that case it doesn't matter. Okay, and according with the numbers of the values given in the independent variable, you are gonna get the dependent variable. In that case, the dependent variable was y, because you got the y values according with the x, and here in that case was x because you got the values of x according with the values of y. So that's why we have a condition. When we realize and we take in account that condition, we are not talking about equation, we are talking about function. Okay, so this is the difference when you take in account. And the algebra representation in that case is not going to be just y and x or x and y. It's going to be different. For example, if I want to make the value, I'm going to write over here, if I want to make the table of values according with a condition, I'm going to write x and, I'm going to write over here f or x instead y. Okay, why I'm telling over here? I'm telling that this value, this variable that is y, depends of the value of x. So that's why I'm introducing the condition. And if I want to do exactly the same, but in that case, and instead to write x and y, I'm going to write over here y and f or y. What I'm telling over here? I'm telling that the value of x depends of the value of y. Okay, so that's why, and instead to talk about equation, I'm talking about function. When one variable is depending of the other variable. And the right form to express a function in a graph is, instead you have x and y, we are not going to talk about any more of y, I'm going to say f or x. It means that x is the independent variable and all the function depends of the x variable. It means that y depends of x, and here the right form to express the graph of in that way as a function is going to be y and f of y. So it means that all the function depends on y and the x depends on y. Alright, so this is like an equation, and here f for x equal to 2 minus x. This is going to be like a function. This is the difference. This is equation, this is a function. Here is going to be the same. This is like an equation, okay, and this is like a function, right? So what is the difference between equation and function? Algebraically, it's going to be something very similar, only the representation is going to be different. Okay, equation is when you have an equality. Function has an equality too, but equation has a variables. Function has a variables, but that variables, one is dependent and the other is going to be dependent because we have a condition. Okay, so it means that in that case this is not an equation. Sorry, this is not a function. It's just an equation because you have variables and equality. And what about this? What about this? Well, this is an equation or this is a function? Well, in that way it's an equation, but in that way it's a function, because you can see clearly that you have all that function depends of x, and here this is an equation and this is going to be a function, because clearly you can see that all the function depends on y. Okay, so this is the difference between equation and function. And let me tell you something. Well, according with the topic of function, we have a lot of concept that you need to know. Okay, as I told you, this is a function. Okay, this part of the function is going to be called in explicit form. Explicit form of function. It's a function explicit, and this is going to be again an explicit form of a function. Why both are explicit? Because you clearly can see what is the independent variable. For example, here the dependent variable is x, here the independent variable is y. We can have different example, like for example, h of s equal to 4 plus s. For example, this is an explicit function. What is the independent variable? S. You can see clearly over here. Okay, but what about this one? We said that this is not a function, this is an equation. Yeah, but sometimes you can say that this is an implicit form function. What implicit? Because it looks like a function, but you cannot see clearly what is the independent variable. It could be y, it could be x, it could be both. You know, it depends of the clear process. Here you can say, oh, this is obviously is y. Yeah, but here it doesn't say that. So that's why this is an implicit form of a function. It's not explicit. Explicit, you clearly see what is the independent variable. In that case, this is going to be an implicit form. Also this one, this is an implicit form. Okay, Good. And the other very important thing that we need to know, another important thing, is the values of the variables. For example, independent variable. Here it was this one, and here it was this one. What is the name of those values that we have in the independent variable? And what is the name of those values that we have in the independent variable? That name are gonna call domain. This is going to be the domain of the function. The domain are all the values that the independent variable, look at this, not x, not y, independent variable values are going to have. Okay, this is going to be called domain. And what is going to be the name of the dependence variables? In that case here, this one or this one, well, that name is going to be range. Okay, the range is going to be the values of the dependent variables produced by the domain. I mean, produced by the values of the independent variable according with the condition that you can see in the function. Okay, so right now maybe I'm going to explain the with an example, and with that example maybe you are going to understand better. Okay, let's suppose that we are going to go to a supermarket. Okay, in the supermarket you are going to see that the apples are going to be, for example, I don't know, 8 pesos per kilogram. Okay, well, look at this. My question is, if you want to buy 1 kilogram of apples, how much you are going to pay for it? The answer is easy, 8 pesos. What about 2 kilograms? The answer is easy, because in that case you are going to pay 16 pesos. What about you want to buy 3 kilograms or 4? So the answer is going to be very easy, right? 4 kilograms, 32 pesos. What about you want to buy 1.5? Well, in that case it's going to be 20 pesos. All right, but what we should do to get that that final cost? So it's going to be very different. First of all, you need to say, okay, the final cost that I want or I should pay for it is going to be very easy. First of all, you are going to multiply the value of the per kilograms apples, and then I'm going to multiply, look at this, I'm going to multiply times the number of kilograms that I'm going to get. All right, so in that case, if I want to buy 1 kilogram times 8 pesos, the final cost is going to be 8. 2 kilograms by 8 pesos is going to be 16, etc. Okay, well, here as you can see we have two variables. This is going to be one variable, and this is going to be another variable. First variable is going to be a final cost. Second variable is going to be a kilograms. So my question is, which one depends on the other one? Is the final cost depending on the kilograms, or is the kilograms depending on the final cost? So in that case, it's very clearly the independent variable is going to be the kilograms, because the final cost depends off. Okay, so in that case I'm going to write this is like a independent variable, and I'm going to represent like a k. Okay, and here this is going to be the dependent variable. Okay, and here the represent is going to be z. Okay, so we have final cost and kilograms. Good. So if I want to convert this one in an equation, look at this, an equation, in that case is going to be equation or function in implicit form, what I should do is going to be C is equal to 8 times K. Okay, this is going to be the equation or function in implicit form. But what about if I want to convert in a function or instead or I'm gonna write function in implicit form. Sorry, not implicit, it's explicit form. Function in explicit form. So what is the dependent variable? Is C, and C depends of K. So you are going to write C of K, it's equal to 8K, and this is going to be the math function. Okay, so if you want to make the graph of this one, what you should do? Okay, first of all, you are going to make the table of values. What you should do, you are going to write over here K, and then we're going to write C of K. So my question is right now, which value you are going to give to K? Whatever value that you want. I mean, can I do -2, -1, 0, 1, 2? Can I do that? So the question is, it depends. If you want to see like in mathematic way, the answer is yes, because you are going to get a value. For example, here 8, well, here is going to be 8 times -2, answer is 16 negative. 8 times -1, answer is -8. 8 times 0, answer is going to be 0. And 8 times 1, answer is going to be 8. And 8 times 2, answer is going to be 16, etc. So in a mathematic way, that yeah, you can do it that. But remember what we are talking about. This is cost. So my question is, it is possible that you can buy -2 kilograms of apples. It is possible that you can pay for it -16 pesos. The answer is not. It's not possible. So in that case, we are not going to take in account the negatives of K, because according with the problem that we want to develop, this is not possible. So we're going to reduce the value of K from here to where? To 3, 4, 5, or infinite? Well, this is another question. Okay, so now the question is, how many kilograms can you buy it? 0? Well, if you want to buy 0, it means that you are not going to buy apples. Can you buy 1 kilogram? Answer is yes. 2, 3, 4, maybe 10, maybe 20. What about if you want to buy 1,000 of kilograms of apples? Well, maybe you want to do that. In the supermarket, you are not going to do that, because maybe they are not going to have 1,000 kilograms of apples available. So it means that we need to establish another limit over here. But it depends on the supermarket. Well, it depends on the supermarket availability, or it depends. Sometimes in the supermarket they say just maximum 8 kilograms per customer. Well, here the supermarket is telling you another limit. Okay, so it means that here I'm going to say 2, 3, 4, 5, 6, 7, and maximum 8, no more. Okay, this is the top of. So you cannot buy more than 8. So this is going to be the limit of. So it means that the values of the dependent variable, I mean this one, is going to be from 0 to 8. Do you remember what is the name of that values? Remember, this is the independent variable. What is the name of that? Yes, this is the domain of the function. Okay, and what is gonna be? Well, first of all, let's fill this chart. In that case, is 8, 16, and here with 3 is gonna be 8 times 3. We're gonna have 24. 8 times 4 is gonna be 32. 8 times 5 is gonna be 40. 8 times 6 is gonna be 48. 8 times 7 is gonna be 56, and 8 times 8 is gonna be 64. Okay, so do you remember, because according with the limits, do you remember the name of that one? Do you remember that? Yeah, the name is gonna be range. Domain, all the possible number of the independent variable. Range, all the possible numbers or values of the dependent variable. So in that case, we're going to make the graph, okay, the graph of the problem. In that case is kilograms, and the cost that depends of the kilograms. From 0 to 8, 1, 2, 3, 4, 5, 6, 7, 8. And here is from 0 to 64. Okay, we're gonna have 10, 20, 30, 40, 50, 60, 70. Okay, and here we're gonna start. Look at this. This is very interesting. I told you that if you want to buy 0 kilograms, you are not going to pay anymore. So it means that you are not going to buy anything. But from which point you are going to start to pay money? From which point? It could be from 0.1, because it represents just 100 milligrams of apples. I know it's impossible, but it can have, because I don't think that exists an apple very small that its weight could be that one. But for example, you want 4 apples, it's not gonna be exactly 1 or 2 or 3 kilograms. It's gonna be maybe, I don't know, grams. All right, could be like I don't know, 800 grams. Okay, so my question is, from which point we're going to start to pay? From which point? From 0? Not, because 0 is gonna be 0 pesos. From which point we're going to start to pay money? Well, this is an interesting question, because it could be from 0.1, or from 0.01, or from 0.001, or etc. So something very approximately to zero we are going to start to pay. So that's why I'm going to start here, but instead to write a point, I'm gonna write a circle, and I'm going to explain later why. Okay, in 0 from comma 0 is gonna be a circle. Good. So let's continue. 1 is gonna be 1 kilogram is gonna be 8. 2 kilograms is gonna be 16. 3 kilograms is gonna be 24 here. Okay, and etc. As you can see, it's going to be a linear, again a linear function. And when you have a linear function, I mean a straight line, is just necessary to establish 2 points, maybe the initial and the final, and then just make the line. So the last one is going to be 8, 64, 4, 5, 6, 7, 8, and 64 is more or less over here. So more or less over here, and then what I'm gonna do, I'm gonna make the graph. There we go. Okay, with 3, with 4, with 5, with 6, with 7. There we go. Okay, good. And here the last point is gonna be a circle, but a very full circle. This is gonna be a open circle. Okay, this is going to represent the function cost dependent of the kilograms that is equal to 8k. Okay, here the domain, as we can see over here, is the value of the independent value. It's going to be, look at this, it's going to be from 0 to 8, and obviously the domain is measured in kilograms. Okay, but look at it, this is very interesting. When you know exactly where a point start or finish, for example, here the top is 8. The top is 8. We know when it finished. It finished in 8. If the top is 8, the cost top is gonna be 64. All right. So we know that it finished. So the domain is going to be something like that, with that bracket. It represents that we know exactly when it finished. But here in this empty circle, we don't know when it starts, because I told you with 0 you are not going to pay anything. So you don't take in account the 0, take in account other number. Maybe it could be 0.1 or 0.2 or 0.01, etc. You don't know exactly which part, so you are gonna do this one. It represents that you don't know exactly where to start, but the point when you are going to start is 0. Well, not in 0, just a little bit more, but you don't know exactly what is that a little bit more. And the range is going to be exactly the same, but it's going to be from 0 pesos. It doesn't include the 0. This means that it's more than 0. Okay, to 64, and this is exactly 64, and in that case is this one. Okay, so here this is an example how to apply a math function in a real case. Okay, so what is the important thing that you need to remember? You need to identify the variables. You need to know how to represent the math function in implicit form, in explicit form, and in graphic form. And another important thing is that you need to identify the domain and the range.